The original work by Stark that introduced the MCA concentrated on the separation of images to cartoon and texture. We now turn to describe this application. Why would anyone want to separate an image into cartoon and texture? This idea came from a paper by Veze and Osher that was published in 2003. Their approach was variational, generalizing the total variation in order to characterize texture. Why separate this way? Because it could help in a variety of tasks, from filtering the content of the image and compressing it, all the way to more sophisticated needs, such as in painting and more. So let's bring MCA and SparseLand to the separation task. Doing so requires us to decide on the dictionaries for describing the cartoon and the texture. Also, we need to figure out how to approximate the P0 epsilon problem we get. The work by Stark and his co-authors did just that. When it comes to choosing DC and DT, the cartoon and the texture dictionaries, global transforms of various sorts were chosen. Let's now see the steps that take us from P0 epsilon to the actual algorithm proposed. This is the MCA formulation, and the first step that this work did was to migrate from L0 to L1. The second step, and this is something we have seen already several times, was to move to the Lagrangian form in which the constraint is turned into a penalty. The process of deriving the algorithm proceeded by moving to the analysis domain. This topic is something we deliberately skipped in this course, but we will say this. We define XC as DC times alpha and XT as DT times beta. These are the actual cartoon and texture images. Suppose for now that DC and DT are square and invertible, and thus we can write alpha and beta in terms of these two new vectors. Then, plugged back to the original problem, the optimization is now done with respect to XC and XT. This is the analysis form. It is perfectly equivalent to the original problem when DC and DT are square and invertible. But when they are not, we get something else and quite interesting by itself. This is our optimization task. The last step in our modifications is to add a total variation penalty on XC in order to avoid ringing effects. Stark suggested an Easter-like algorithm for handling this problem, which we will not discuss here. And here are the results, first on a synthetic case. The image on the top left is the original mixture. The dictionaries used for the separation are curvelets for the cartoon and a global DCT for the texture. Since both these dictionaries believe that the smooth content in the image belongs to them, we remove it beforehand to avoid confusion. This part is shown on the top right part. The bottom shows the texture and the cartoon. The smooth part has been added to the cartoon where we feel it is better suited to appear. Here is the same experiment, and this time with additive noise. As you can see, the algorithm manages to decompose the image into the noise, the cartoon, and the texture in quite a convincing way. What could we do with such a separation? Here is a demonstration of a simple edge detection that we apply on the given image by applying it to the cartoon only. Applying the same edge detection on the original image is cluttered by the texture derivatives. Here is the image Barbara, which has very interesting textures in various regions in the image, and here are our results. This time the texture was obtained using a local patch-based DCT, while the cartoon remained with the curvelets. How do these results compare with the variational alternative? We see here two portions of the image Barbara after the separation. The left are the MCA results, while the right ones are created by the variational approach. You can see that in the MCA the separation is more conclusive and more successful. As a last example, we show this image captured by the Gemini space probe. This image shows a galaxy masked heavily by both random and structured noise. The separation to these three ingredients is very successful. Observe how the galaxy is now seen clearly and how the disturbance parts are extracted nicely.